Across the global mining industry, machines have always shaped the limits of human ambition. Bigger iron meant deeper mines, higher tonnage, and new levels of productivity. And among all the giants that define modern mining, one machine stands at the top. A truck so large, so powerful, and so influential that it reshaped the entire ultra-class haul truck market. This is the story of the Caterpillar 797, the most legendary mining truck ever built. A truck developed with a very specific customer in mind, and a truck that would go on to dominate some of the harshest work sites on Earth, including the unforgiving oil sands of northern Alberta. By the early 1990s, haul trucks had been growing steadily, but they still fell short of what the next generation of large mines needed. Operators in places like Nevada and Queensland were digging deeper and moving more material every year. The global mining boom was unprecedented, yet nowhere was the need more urgent than in Canada, where companies like Suncor were rapidly expanding operations in the Athabasca oil sands. The oil sands placed enormous stress on mining equipment. The material was heavy, sticky, and abrasive. The cold winters regularly dropped temperatures far below freezing. The mine sites demanded continuous round-the-clock hauling with minimal downtime. Suncor made it clear that existing haul trucks no longer met the production levels the industry was pushing toward. They needed a machine that could carry more, last longer, and survive in a landscape where conventional machinery struggled. Caterpillar recognized the opportunity. In the mid-90s, the company began the development of an entirely new flagship haul truck. The goal was simple but unprecedented. Build the largest, most durable, most capable mechanical drive mining truck the world had ever seen. One that could thrive in the oil sands as well as every major mine across the globe. The project was centered at Caterpillar's large manufacturing facility in Decatur, Illinois, where engineers used advanced digital modeling tools and new manufacturing processes to design a truck unlike anything before it. The first-generation Caterpillar 797 rolled out of the Decatur plant in September 1998. It entered full production in 1999. Right from the start, the 797 captured the industry's attention. It featured a massive payload rating of roughly 360 short tons, placing it at the very top of the mechanical drive haul truck class. Inside the frame was a purpose-built power plant created specifically for the giant 797. Caterpillar equipped the monster truck with the 20-cylinder 3524B engine, which could produce around 3,400 horsepower. This engine was not available in any other Caterpillar machine at the time. It was engineered exclusively for the demands of ultra-class hauling. The 797's frame, axles, transmission, and suspension were all developed from the ground up to handle extreme loads. Everything about the truck was oversized. Tires nearly 4 meters tall, brakes capable of stopping the full load on steep grades, a mechanical powertrain designed to maintain speed on long hauls where electric drive trucks often lost momentum. Caterpillar sent the first units straight to the customers who had helped define the project. Several of the earliest trucks went directly to Suncor in the Canadian oil sands, confirming that the truck succeeded in the environment it had been built for. The performance was exceptional. Mines reported high reliability, strong cycle times, and remarkable durability. One of the first units delivered to Canada went on to surpass over 150,000 operating hours, an extraordinary lifespan for a truck working in such punishing conditions. By the early 2000s, the 797 was already famous, but it became legendary for 3 reasons. The first was its mechanical drive system. In an era when most ultra-class trucks were turning toward electric drive technology, Caterpillar doubled down on mechanical drive and proved it could work at the highest payloads. Mechanical drive was easier to service, required fewer specialized components, and excelled in mines with long, flat hauls. The second was uptime. The 797 delivered consistent performance in places where other machines struggled. Oil sands operators praised its resistance to cold weather failures. Hard rock mines appreciated its ability to maintain speed on long ramps. Across the world, the 797 earned a reputation for reliability that few ultra-class trucks could match. In no time, South Africa, South America, and Australia were taking delivery of their units. The third was operator and technician familiarity. Caterpillar designed the truck around systems that mines already understood. That meant faster adoption, easier parts access, and lower total cost of ownership. Word spread quickly. The 797 was not just the biggest truck on the market, it was often the most dependable. In 2002, Caterpillar introduced the second generation 797B. It increased the payload rating to 380 short tons. It also delivered improvements in power, braking, and serviceability, building on the real-world lessons learned during the early years of oil sands operation. The B model strengthened Caterpillar's position in the ultra-class market. As mines continued to expand, the demand for trucks of this scale grew sharply. The new version worked not only in the oil sands but also in massive copper, iron ore, and coal operations around the world. The 797B was the confirmation of an engineering success. It proved the mining truck wasn't just a vanity factory performance designed for headlines only. It was a true workhorse able to take an entire industry to the next level, and it sure did. The most significant update arrived in 2009 with the introduction of the 797F. This version pushed the payload to approximately 400 short tons, firmly establishing it as one of the largest mining trucks on Earth. The 797F also replaced the aging 3524 engine with a new power plant. Caterpillar introduced the C17520, a 20-cylinder engine producing around 4,000 horsepower. This engine offered better fuel efficiency, improved emissions performance, and higher power density. It quickly became known as one of the most impressive mining engines ever produced. The 797F received major upgrades to its frame, suspension cylinders, electronic systems, and operator environment. Caterpillar redesigned the cab, improved visibility, and added advanced monitoring systems that allowed mines to track performance, maintenance, and fuel consumption with greater accuracy. The result was a truck that became the industry standard. Oil sands operators, especially Suncor, adopted the 797 degrees Fahrenheit heavily. Large open-pit mines in the United States, Chile, Australia, and Africa did the same. For more than a decade, the 797F dominated the ultra-class segment. As demand and adoption grew, the $5 million 797 became one of the most successful haul trucks ever manufactured. In 2018, Caterpillar announced the production of the 1,000th 797 unit, a major milestone for a machine of this scale. It was a clear sign of how deeply the truck had integrated into global mining. The 797's impact went far beyond the mines that operated it. It influenced infrastructure around the world. Roads, maintenance facilities, fuel systems, and equipment transport procedures were redesigned to accommodate trucks of this size. Training programs evolved around the truck. Entire logistics strategies were shaped by its capabilities. The 797 also demonstrated the economic value of ultra-class hauling. Mines realized that fewer larger trucks could outperform larger fleets of smaller units, reducing labor, fuel costs, and maintenance hours. The truck helped define the modern philosophy of high-tonnage surface mining. The 797 holds a rare distinction. It was not only one of the largest machines ever built in the state of Illinois, but was also recognized as one of the greatest industrial products the state had ever produced. In 2020, it was named the coolest thing made in Illinois, beating out a wide array of advanced manufacturing products. The Decatur plant became one of the most important heavy manufacturing facilities in the United States. Building a 797 required an enormous combination of skilled labor, robotics, precision welding, and careful inspection. Each truck was assembled from major components shipped in from Caterpillar facilities across the country, then tested and validated before delivery. Today, the 797 remains one of the most iconic machines in the mining industry. While autonomous mining trucks are becoming more common, many operators still value the 797 for its features including simplicity, extreme durability, and proven performance. Its legacy is unmistakable. In the history of mining, no other truck carries the legacy of this giant. It showed that ultra-class hauling could be done at scale, reliably, and economically. And it proved that designing a truck around the needs of its customers, especially in the oil sands, could reshape an entire industry. More than 25 years after the first 797 rolled out of Decatur, the truck still represents the peak of what heavy industry can build, a symbol of engineering ambition, a benchmark for haulage capacity, a success that competitors tried to match but none ever truly equaled. The Caterpillar 797 is more than a mining truck. It is a technological landmark. From the frozen oil sands to the blazing iron mines of Australia, it has carried billions of tons of material and reshaped the landscape of global mining. It stands as proof that when industry demands the impossible, engineering rises to meet it. And for that reason, the Caterpillar 797 remains the most legendary mining truck ever built.